Alright, here is a displacement problem. It's a little tougher than ones I've done in the past. In this case, a bird is flying 10 miles south, so I can draw that. And then they turn and go 6 miles at 25 degrees north of east. So if this is east, 25 degrees north of east will be this. That's 25 degrees. And they go 6 miles in that direction. So they started here and they finished here. And we want to know the length here. And it's not as simple as other ones because I've not created a right triangle here. This is not a right angle. So I can't use the Pythagorean theorem. It's a little more complicated. So you can play around with geometry to figure this out, or we can just consider the vectors separately. So we have vector 1, which I'll just call V1, and we'll have vector 2, V2. And we break them down into their individual components, x and y, x and y. So this first one, 10 miles due south, it has no x component because it's straight down. It's not going to the left, not going to the right, so that's just 0. And if it's 10 miles south, then the y component is 10, but since it's going downward or south, we'll call that negative 10. So this is what we can express the first vector as. Is x is 0, y is negative 10. The second vector is a little tougher, so I'll redraw it. It's 6 in this direction at 25 degrees. So I'm going to have to use some trig. Here's my y component, here's my x component. So again, back to V1, the sine of 25 degrees equals y over 6, and the cosine of 25 degrees equals x over 6, just using some trig. So solving for each of those, for my y, I get 6 times sine of 25, and I get y equals 2.54. And for my x, 6 cosine 25, I get 5.43. And I just want to double check the signs on this. This is going up and to the right, so both of these will be positive. So I just want to double check that because the trig will not tell you the signs. So basically that's V1 and that's V2. So the entire trip is the sum of V1 plus V2, and that gets you here. So what you can do is add these components. What is V1 plus V2? Well, x is 0 plus 5.43, so the x component is just 5.43. And the y component is negative 10 plus 2.54. So I add those, negative 10 plus 2.54, and that's negative 7.46. So that basically tells me if I redraw a new triangle here, it's telling me I'm going over 5.43 and down 7.46. And this is a right triangle. I can find the length here using the Pythagorean theorem. So I'll do that. So basically what I've done is I've created a triangle with this is the x, that's the y. So 5.43 squared plus 7.46 squared. And you notice I got rid of the negative, and I don't have to. I could keep the negative in there as long as I remember to put it in parentheses. Your calculator won't process it properly otherwise. But I just usually get rid of the negative. So that equals c squared. So I'm just going to do that real quick to get a final result. Take the square root of both sides. So I get c is 9.23 miles. So the length from here to here is 9.43 miles. And again, the easiest way to do that was combining the vectors, the components of each vector, and adding them together. So what I would do is just draw each vector separately and then analyze the x and y. You don't even have to draw them together. So the x and y for this vector, the x and y for this vector, and then add them together. So that's it. Until next time, I am Derek Genova. Have a delightful day.